This is a production of Cornell University.
Okay, so as Nina just demonstrated, soils are composed of different percentages of different sized particles, sand, silt, and clay. We have a technique we can demonstrate now that will give us an approximation of those representative percentages. Those percentages are indicated on the USDA texture triangle, which we also have with us here. So this technique that's going to give us an approximation of the percentages is going to give us an indication of the soil texture. And so by running through this flowchart here, we're going to end up with a sort of rough estimation of the texture of these two samples of soil. So we have two samples here, and I'm going to start with this one here, and we're just going to run through the process on our flowchart. So it starts with taking a small amount of the soil in the hand. This is soil texture by feel or by hand. And we're gonna sort the soil a little bit, removing sticks and stones, elements like larger than the largest particle sand that do not form part of the overall textural composition. So I'm just pulling out the stones, looking for, some of these are just large particles of soil that are kind of glued together. I'm just going to remove those. I'm just going to get down here to just the basic composition of the soil here. Again, I'm just kind of sieving them out, filtering them out. Okay. Last pieces of gravel here. All right, once I have what is pretty much just the soil left, these are just field soils, just dug. I'm going to wet the sample. I'm going to place just a couple drops. And the goal here is to form a ball. I want to get a ball of soil that's roughly putty-like in consistency, something that kind of holds together. So we're just going to keep wetting until we get there. Let's add a little more soil. We want about a little golf ball size. So we have enough to run our diagnostic on. Just kind of mixing it in my hand. What we're going for here is we want the soil to form a ball. This is the first part of the test, if it will form a ball. Okay, there we go, we're pretty close. Give it a little more. You know you're just about there when your hands are covered in dirt. Okay, now reading through our flowchart, the first questions it'll ask is, will the sample form a ball when squeezed, right? So I'm going to give it a little squeeze, and it retains its shape. If it then wants to just kind of shatter and fall apart, following through the diagnostic, we end up with that your sample is sand. So this is not just sand. We move on. Okay, so the next part of this test is to try to form a ribbon. And the ability of the soil sample to form a ribbon and hold it is going to be a measure of the percentage of clay. Okay. So to form a ribbon, you can take the sample in your palm of your hand like this, and you start to kind of squeeze and feed it out. And you want it to break naturally and fall, okay, to the table. There it goes. And you do that a couple times, and each time estimating the length. So here we have about 3/4 of an inch. Put it back into a ball form. It's dried out a little bit in my hand. Feed it a little more water. We don't want water to be squeezed out. Okay, going back to forming a ribbon. Squeezing it out. And fell, this time we hit about an inch, okay? And we'll just do one more ribbon. And we'll take the average of the three. Okay, there it goes. And it shattered when it hit, but just under an inch. Okay. So now following through our flowchart here, diagram, I'm reading, yes, we have a ball, and the ribbon formation, we had an inch or less, so we're in the loam category. All right, so the next part of the test is to estimate the percentage of grit or sand in the sample. So I'm going to take a little bit of it, put the rest aside, about a teaspoon or two here. And I'm going to wet it in the palm of my hand. And this process is intended to, I'm going to kind of flatten it out, estimate the percentage of sand as a factor of how gritty the soil sample feels. Okay, so the diagram asks us, does the sample feel very gritty, equally gritty and smooth, or very smooth? So kind of just got to give an estimation here. It's somewhat gritty and somewhat smooth. It's kind of feels somewhere in the middle. Okay, so the diagnostic has led us to the conclusion then that this sample is a loam. So I'm going to listen to the sample and see if I can hear the sound of the grit rubbing. Yeah, and I can hear it just a little bit. It's somewhere between a loam and a sandy loam then. And so if we turn to the texture triangle, we can actually then convert that diagnosis into percentages of the various particle sizes, right? So reading here, we have a sandy loam being composed of something around 20% clay max and somewhere between 70 to 50% sand. And a loam being as low as 30% sand. So we're probably somewhere down in that 30% to 40% range, below sandy loam. Yep. Okay, so let's try the next sample. By appearance alone, there's not really much we can tell. There's no way to visually distinguish these two soils in terms of their texture here. But by running through this soil texture by feel, we should be able to make some conclusions. Let's make sure we get all the last sample off. Okay, and again, we're going to sort the sample a little bit, moving some roots. Make sure we have a sufficient quantity there to get our ribbon. And wetting the soil. A little more, it's still not quite consolidating. Just a little bit more. Okay, yeah, it's starting to form a little film on my hands, so we should be there. You don't want to oversaturate it. Okay, going back to our flowchart, the first diagnostic is to see if the sample will form a ball. And here we have a nice ball. So, and under a little pressure from the finger, it doesn't fall apart, doesn't shatter. So we know we don't have a sand sample, as we suspected. Give it a little squeeze. Still stays together, stays put. So it's not a sand or a loamy sand. So we're going to move down into the next step, which is the ribbon forming process. And get it teed up in my hand, right? And start feeding it out. And right away I can tell that it's forming a longer ribbon. This one broke when it hit, but there we have maybe 1.25 inches. Run that 3 times. And I'm just going to let it naturally just feed over my forefinger until it wants to fall, okay? All right. There may be almost 2 inches. And one last sample. All right, maybe 1.5 inches. So about 1.5 inches average, and just under that. So reading across, we've gotten into the clay loam category. Okay, so now we need to estimate the amount of grit in the sample. So I'm going to take a small portion of it in the palm of my hand and re-wet it in order to form a film. Try to get a sense of the percentage here. Recalling that this relates back to the percentages of the various particles in the texture triangle. Okay, already I can tell there's some grit there, certainly, but I'm not feeling as much as the previous sample at all. And I'm listening. There's a little bit of sound of friction, but not a lot. Certainly less than half, so we're more on the smooth side with this one. Reading down, somewhere between clay loam and a silty clay loam. So let's see, going over here to the texture triangle, finding a clay loam here and a silty clay loam here, we can tell then that we're somewhere between 30 to 40% clay. We didn't move much, but we didn't move the percentage of clay very far, but it definitely changed the characteristic qualities of the texture of the soil. So it became more smooth, more capable of forming a longer ribbon, with just a little bit more clay. And it changed just that small amount of adjustment changed the soil texture for us in our diagnostic.
This has been a production of Cornell University, on the web at cornell.edu.